Hey, and welcome to my brief introduction on artificial neural networks. The brain is one of the most complex systems known to man, made up of an intricate web of cells called neurons. With over 100 billion neurons processing and linking information extremely quickly, people began to emulate this structure in order to solve problems. Hence, the artificial neural network was born. These networks could be used in many applications, but were frequently found excelling in classification and modelling problems, including pattern recognition or modelling hydraulic systems, where once trained they proved to be extremely efficient. So what does an artificial neural network look like? Well, this, a series of nodes connected by weighted links. These nodes are organised into layers, the first of which being the input layer. Nodes in this layer simply take a value for each variable into the system. These values are then fed forward via the node's associated links. Every node has a link to every node in the next layer. Each link then has an associated weight. Every value that passes through the link gets multiplied by this weight before continuing through the network. As our network has 4 nodes in the next layer, every input node has 4 links, for a total of 12 links. It should be noted that each link is unique and its weight independent of all others in the layer. The next and most important layer is the hidden layer. Each node in this layer sums all its associated links to create a new value. This new value is then passed through a function assigned to the node before being passed on to the final layer again via links. These links work exactly the same as those between the input and hidden layer, with each having a weight to multiply their transported value by. We only have one output node, so each hidden node only has a single link. Finally, we have the output layer. Nodes in this layer also sum the values passed to them via their links. Once summed, this value is then returned to the user and should be interpreted for the system being modelled to be of use. This leaves some questions that need to be discussed, especially as weights and functions are set arbitrarily. The magic happens when training the network. By passing variables with known results through the system, we can compare its output with the known result. This comparison gives us an error value that can be backpropagated through the network. Working backwards through the network, links are altered according to their influence on the output. Weights impacting the output most are changed proportionally to the calculated error in order to reduce it. After sufficient training has been completed, so as the error is consistently below a given threshold, variables with unknown results can be passed through the network to predict results for the system. Neural networks are widely studied by computer scientists, creating looping networks and devising ever more efficient methods of backpropagation. Questions are commonly asked about how long you should train a network for, or how many nodes should it contain. Unfortunately, I don't have the answers here, because these questions are being explored every day. All I can say is artificial neural networks are a powerful tool and are likely to become more common in computing over the next few years. I hope this has been informative, and thanks for watching.